The following content is provided by MIT OpenCourseware under a Creative Commons license. Additional information about our license and MIT OpenCourseware in general is available at ocw.mit.edu.
So in the afternoon, we want to go back to the model room for another visit there to look at those plans with a more informed eye, and kind of hoping for you guys to lead the discussion most on that stuff. And once we're through there, we'll go up to the plans collection. MIT Museum has an amazing collection of plans, boat design plans, and so we'll look at different methods of drawing boats and how they suit the design. And wrap up the class that way. I think that the final thing is to do a little debrief, with you at your models and talk about where you've gone and what you see, and also, bringing it back to the method, strengths, weaknesses, things you can see with the method that you can't otherwise. But before we go up there, there's one key step of translating this into a form that can be built from, which is coming up with a table of offsets. Every plan will have this little table, which is basically ordinates on the grid, so that when if I'm building this boat and I need to loft it to draw that full size, I need to know, where these points are on the station line. So this is important in terms of looking at the plans collection upstairs. So Tony, lead the charge here.
Again, if you've got your virtual model in CAD, you basically press a couple special keys, and the thing can print out a set of offsets to whatever accuracy you want, or you can send a file to a 3-axis or a 5-axis mill and actually just create actually physical stuff that exactly fits the shape of that you've designed. But again, back in pre-virtual world, you needed to take the drawing, which you've done, and I think you've all kind of got a sense of how, with a little practice, that you can kind of tell if a line is half of a pencil line too fat or too skinny in places, and how you kind of honed things down to, at least at scale, to where things are almost imperceptibly different, but that you've noticed that there's a difference there. Well, of course, to scale that up, we've been dealing in scales of 3/4 or inch to the foot, or 700 inches to the 700 feet to the inch, like on the aircraft carrier. But so you can imagine when you scale up that this very fine accuracy that we thought we had in the model is really nothing when it comes to real life, and that the width of the pencil line can be anywhere from an eighth of an inch to a foot and a half, depending on what scale you're working on, and that ultimately you're going to need to resolve all of that in the lofting. But to get from this to the lofting in a systematic way, the convention of having a table of offsets was evolved, where, see, there are the half breadths from the center line, and then each of the station, the perpendiculars and each of the stations are listed here. Then you've got a set of diagonals, which are these diagonals shown here, and then here are the heights above base, or heights from the datum waterline, or however that wants to be laid out vertically, and for each of the stations. And the numbers in here were arrived at by having the eagle eye that did the drawing working the scale rule, and you find with practice that you can kind of imagine that yourself looking at an inch to the foot scale, that you can actually tell what a 1/16 of an inch looks like on here. I mean, you can't really prove that it's true, but you kind of can talk yourself into thinking that you can. And in which case, you then have your assistant write down the first number. They're written in as three numbers with a dash. So this is 1 foot 9 inches and 5/8. Okay, and then sometimes you might see a plus sign, which means that they think that there's another 1/16 on that too. So then you go through, and at that point you really are kind of just.
I just want to physically lay out.
Sure,
Just so no intuition allowed. This is, if you, whatever your scale is, you lay your scaling rule at station 7. You know, you're putting the, you're making a measurement, so you know it's 1 foot and 5.5 inches, whatever it is, to this water line. So when I'm lofting the boat, my first step is I just draw the grid, right? And then I go back and I make a mark at 1 foot, 1'7" full size.
Right,
So literally
right.
so that's a half breadth off the center line. And then if we had a datum line here, I'd have heights for the shear, measured in exactly the same way. So,
Right. So
so if it's not incredibly obvious, hopefully that made it so.
Right. And so that once this is all filled out, then the builder, starting with that basic grid, can then fill all these back in again. And but actually the builder laying out the grid is going to hopefully again not just sort of start on one corner and just sort of fill this thing in, but it's going to recapitulate the same kind of proof that we've done in the drawings, where you start with the master lines and you reconcile those, and then you keep on gaining information as the same method of deciding which should I believe, which one should I hold on to, which one should I adjust to reconcile with the other. And because there will be a tremendous amount of interpretation when an eighth of an inch is basically less than the thickness of the tick on the ruler, and you want a result that's good to an actual 1/16 of an inch in full size. And then also there could be transposition errors in here. Lots of famous yacht designers have made horrible offset tables because they just were dyslexic and wrote the things backwards or missed things or just got them out of order, and those things were in there for the builder to have to deal with, and much easier to sort that out methodically while you're actually laying out the lofting than it would be to just sort of make each mold believing that these offsets were correct for each station, standing them up and then going, well, wait a minute, this didn't work. Why isn't this working? And then you're not having any idea why. Then also once these lines that give you the shape of the boat have been laid out on the lofting, then depending on the construction method, the builder can start making actual decisions about how the actual pieces are going to be laid out and constructed, and be able to make deductions for the thickness or width or intersection of pieces with each other. And a lot of pieces can actually be built, are built, not just molds, but actual, the whole backbone of a boat.
Pattern a backbone, you can schedule the fasteners so that you may put a fastener that's hidden, but you can schedule it on the loft. So I know I got a big drift pin here. Then I know that coming from the other side, I can't put a screw. On this side, you can take all of that kind of thought process out in pencil, and also all the bevels. The angles that the planking comes into the backbone. I can pick up those shapes right on my backbone, so that when it comes down to planking, they just lie right in. They all work. This another thing is that whereas the tools that you use to create, when you started, you had a point here and a point here and a point here, but to fill up that space in between, you use the curve, the plastic curves to occupy that space. But if I'm lofting this boat, and this thing, that might be 3 feet apart. So the way the tool for creating accuracy in that space there is called a fairing batten, and it's a long piece of wood, usually longer than the boat is long. It might be 22 feet long, and of varying thicknesses. It might be 1.5 inches square, and you actually bow that wood to follow a line, so it meets all the ordnance. And then you get down low, same as before, and you sight the curve and you look for fairness, and that's how you judge if the ordnance that you were given are accurate, right? So you draw those lines. So in this case, I would draw this buttock line up to maybe here, then I might draw this water line back to here, and judge how they all work, and then later on connect the two. But I usually start drawing these and reconcile, make sure these look all fair before I draw these, because it's so much easier to sight that long gradual curve than it is these very tight sudden bends.
Yeah.
And I can see how they all go together.
But then any inconsistency that you find here, you've got to trace it back and fix it back in there, because if you find that this station right here is off at that intersection, and you make an adjustment, well, you might find that then that's going to affect when you bring that back up here, that's going to affect this station and this station,
Yeah.
and then it all ripples through.
And there's like zero wiggle room. I mean,
Right.
it has to reconcile. Otherwise, it's not buildable. You can,
right,
you know,
right.
don't
Yeah,
ever
you're just fooling yourself. yeah, right.
As you can sometimes.
And you know, this whole process of lofting, you know, everything from you know, big ships to you know, little canoes were lofted this way, and this whole technique was lifted and was used, has been used again in aviation. To, you know, every airplane ever built was you know, before virtual modeling was lofted too, and in fact the whole terminology and methodology of designing and building airplanes uses all the same terminology and methodology that was evolved here. You know, if you have a CAD program, it'll give you a choice of setting things up either with a, you know, kind of the architectural standard of, you know, of XY and that's used for buildings and for landscape or whatever. But then you can set it up on aeronautical, and aeronautical is really nautical. It's this setup, you know, so that you know, X, Y, and Z are laid out to be used for this kind of thing.
So I think that's, I mean, that was just that last step. You know, how do you've translated this, and now how do you make it into a buildable form? Is creating those offsets. It's pretty straightforward. But we'll look at the loft again down by the model room, and maybe now that will resonate a little better.
Yeah.
One question: would you go directly from the model to CAD, or would you actually kind of draw a little bit and then do that in CAD?
Well, these days, you know, what you could do is if you had access to the right machines, you could scan the model, and that would be the you know, if for some of you who went further with the model, that would actually right now, you know, in the practical reality of who you are and where you are and what you have available, scanning your model and continuing from there, or digitizing your drawing and continuing from there would probably be more realistic and even more interesting to you than trying to continue finding ways to deal with this particular woodworking or hand drawing you know, techniques, which are of more historical interest, really, in a pragmatic sense than anything else. So.
It will work directly into CAD.
Well, the one for you, yes, because you haven't done any of that. You might as well skip it directly. But for instance, for the ones of you who've gone further with the drawing, you might want to do a combination of scanning the model and digitizing the drawing, and then actually putting them together. And then, wow, you really open up a whole sense of how all of this stuff came together. And then, you know, once you're inside of the box there, you can start exploring all of the freedom and detail, you know, the specificity that you can combine in that format.
It's a matter of familiarity with the tools too. I mean, that's
right.
I mean, like the woodworking part, I'm more familiar with those tools than I am any of the drafting tools.
Yeah.
And I would probably, for myself, I would trust my own judgment on a model more than I would the drawing. That's what I'm more accustomed to.
Right.
You know, because I know how those tools make those fair curves. I know how to make them do it because I've been planing wood for 35 years. But you know, if you're more accustomed to a computer and understanding the shape that way, then that's a fantastic tool. It's better than mine, really. So.
But here's one thing that I think that because of your experience here, you're going to have a more finely tuned sense of what to do in CAD than people who just started directly in CAD, because I think you've been able to realize how if you don't take control of your tools take control of you, right? And the easier the tool is, the easier it is for the tool to take control of you. And so you'll find that this is starting to become less of a problem, but 15 years ago or so, when CAD design and boats started to first interact a lot, every CAD boat looked like every other CAD boat because people were being dominated by the technology as opposed to using the tool critically. And that's that when I talked about the transition that I had to personally go through, I could have gotten rid of a lot of the trouble of that if I had just accepted that and said, oh, okay, well, in CAD, all boats are supposed to look like that, because that's how boats are easily done in CAD, But I didn't want to do that, so I wanted to bring what I'd learned before that and force CAD to do what I wanted to do instead of the other way around. So in a lot of ways, this whole experience is probably going to help you a lot more, not get just sucked into the cliches that CAD will set you up for. Okay,
Yeah,
so
and we definitely stuck with, for this method, we generally stuck to more traditional forms because the method suits it. It really does. And even the way the tools work, you can kind of replicate in your mind how the planking would run and how the boat might be built. So.
yeah.
But we should move on anyway.
So just one last thought before we go up. When we get up to the model room, I really would like each of you to look at all the models with a critical eye of which ones of these have the most bearing on what I've been working on, and then to come up with questions that you can share with the group, or comments or whatever, so we can have a bit more of interaction, because at this point we do have, each of you have some specificity that you can bring to bear, some starting point to bring to bear to this. So we should be able to make this more of a discussion.
So shall we?
We're gathered here in the collection storage area for the MIT Museum's archival collections and photographic collections. Almost all of our paper-based and photographic-based collections are in this area back here, and the two largest design collections that we have are what we refer to generally as the Hart Nautical collections. It's a series of collections that range from shipbuilding archives and yacht design archives, various designers and builders from old MIT alum in Nathaniel Green Hershoff, class of 1869. He was a special student in mechanical engineering here at MIT. Back in those days, there were special student status. You could study whatever you wanted to study, but he didn't actually get a degree, but he studied here for, I think, 3 years.
So we can't use his plans then, right? He doesn't have a degree.
No. So anyway, there's various collections that have a distinct MIT connection, like Professor George Owen's design collection is here, and of course many of these yacht design firms or the shipyards employed MIT grads, not just in naval architecture and ocean engineering, but mechanical engineering in various areas. So to some extent, it is a little bit of it's a record of U.S. Naval and record of U.S. naval architecture and marine engineering from, we'll say, about mid-19th century right on through today. And as I was talking to you earlier, we're still documenting, we're still collecting. I'm talking to alums from 1970, 1975, and getting their stories and actually collecting technology, sort of where this technology has evolved to. So it's an ongoing process. But what we've gotten out here for you today is just a fragment of some of the material that's here. I did want to point out that behind you and on this side here, all these flat files contain not just the Hart Nautical collections, but we have an architecture and design collection that represents largely student work here at MIT. The first school of architecture in the United States was MIT, and actually the first school of naval architecture and marine engineering was, first four-year college program in the United States was here at MIT. So, 1866, I think the first classes were, right after the Civil War, I think is when the first classes were. And so that's the beginning of formal architecture education in the United States. And then what we used to refer to as Course 13, because now it's merged into mechanical, started in 1893. And so in this room you have one of the most unique design collections probably anywhere in the city, and I would argue there are few other museums that have a world-class architecture and naval architecture and marine engineering design collection. So it's a design library, and right now it's sort of how to access it. It's more or less analog. We've been doing a little bit of slogging away at trying to convert the access to a digital access. We literally are going to have an online database starting this summer, probably not till August, and you'll be able to go in and access 38,000 records in the Hart Nautical collections. There's going to be a web interface to our database. We're in the process of buying a new database. So you're not going to be able to see too many images of the plans, but you'll be able to search across. And this is going to be a phenomenal breakthrough for all the people who utilize the collections right now. And then we're going to start scanning this material in. So you'll be able to, as a design library is a library that you must be able to visualize the material. You can call up and say, I'm looking for this kind of stuff, and you can get records that say, well, there's sort of this kind of stuff, descriptive records, but as you all have been experiencing, visualizing both three-dimensionally and two-dimensionally is really critical. And what's depicted on the plans is a lines plan is not a lines plan is not a lines plan. There's similar information across lines plans or construction plans, but it varies. So what we have here is we have a preliminary lines plan. Frank, if this is Bernice.
Yep.
This is a P-class, Universal Rule P-class boat by Professor George Owen, and you walk by an exhibit that you may want to
we'll look at that.
take a look at that on your way out. It doesn't have any lines plans. It has construction and sail plans, and then some representative models from the collection. And George designed on the board, meaning George did not design as you have been working this week. George designed, he didn't design with a model first. He designed scientifically, the newfangled way. And as Tony has been hammering, I'm sure. Now you said there was a final. Actually, I wouldn't really call these.
Right. Well, that's one that was apparently sent to the shop, and then they used that to expand the lines.
Well, what I'm referring to is there may be a couple of working examples of the lines, and you'll see all the erasures, and this will all be this is all familiar to what you guys have been doing to some extent, and then generally in a design collection you will find inked lines. You'll find a final where they've resolved this is it, this is the final, and it's a sort of a documentation of that final shape that was, we'll presume, the built shape.
And
Now,
the next one down is an detail.
and then I'll let Tony talk about some of these in detail. I just wanted to kind of give you a review of what we got. This is all one boat. This is a boat that still exists today. It's actually being restored up in Rockport, Maine at Rockport Marine. And so we just met with the owner of the boat just recently, and let's see, what's a P boat's overall length? It's about
50s, I think.
Yeah, what is this, is 50 feet, or 55 or so.
Yeah,
50s,
55 foot overall. So it's a really sizable yacht. And so this is this is his approach to a construction plan, and you'll see what you're looking at over here is a construction plan for Bibelo, which is a Sonder class boat by N.G. Hershoff, and it's similar to the models that we pointed out to you that have the really narrow waterline but lots of overhang, and when it heels, it's waterline length. And there was a replica of this boat that was actually built up in Maine about a decade ago for a German client. This class is still alive on German lakes, and there have been a couple of replicas or reproductions built. And then let's see what else we've got. This is so this is the N.G. Hershoff collection, or the Half-River Hershoff collection, the George Owen collection. This is from the Davis Hand collection. William Hand was a Maine designer who practiced most of his from Maine, but practiced mostly in Massachusetts, down in New Bedford. And his early contribution is he was doing power boats at that early period, in the early teens, when engines were internal engines were starting to sort of take over from steam or be a whole new power solution. He was doing lots of experimentation, and he was building boats that were actually quite sea-kindly. They were sort of pioneers of the deep V section. So your boat, for example, it's not a power boat, but it's a chine boat, and if you had more of a V section in the run of the boat, the shape from midship back, it might be a more sea-kindly type of boat, or you might be able to take it in heavier waves. And you'll note here that these lines here, this last line, you've discussed what the lines represent and everything, so everybody's familiar with that. In the body plan here, you'll see the angle of this. This is the last line near the transom, or excuse me, I'm pointing the wrong one. This line right here would be the last. That's essentially the transom, I believe, right there. And see, right at the transom, there's a fairly good V section, and there's more of a V section going forward. So it wouldn't pound in a seaway, even though it's a chine boat. It would actually, and a lot of the other power boats in that era were actually go-fast lake boats, and they were really, they basically damage your kidneys if you went at speed. So this is early power boat, and it was really innovative at its time. Today, that is, for that type of boat, that's more or less a kind of a hull form that's successful at sea. I think I'm. Stop in and argue with me if I'm wrong.
You want some gloves for that?
Sure. And this is this is similar to the model I showed you down in the model room. I keep this up here to sort of demonstrate. I mean, it's a very rare artifact, and I probably shouldn't be taking it apart all the time. But I wanted to demonstrate the system here.
It can't be too moist in here.
It's pretty dry in here, so you
think I'm going to walk over
and I don't usually jam them in, but this then begins to illustrate for you how this works, or better yet, we'll
See how much more directly you can go from model to plan this way.
Well, yeah, I mean, it's effectively working in the same manner as taking the sections, right?
Yeah.
But you're just taking sections in a
different
plane.
way, a different plane. Yeah.
So, but from this you can extrapolate. So from this you would extrapolate those sectional shapes, right? Rather than the other way around.
You see that radical down here is we're really getting radical as we're getting
Yeah,
down
and you
to
can
where
see
the
that
shape is radical.
you can see that this kind of shape is the line of the hull is too oblique. This is a really nicely carved model, so it's still a fair line, but a little tiny, too much sanding here would make that line wiggle, and so, reliability goes downhill for that waterline plane.
Yeah, the
as you
difference
go
in
into
reliability between this part right here and that there
There's
is tremendous.
There's a little bump there.
I guess I got this turned the wrong way, don't I? It should be this way. Right?
Yeah, that way.
I mean,
it's good to see.
It's actually maybe better to have them turned this way, huh?
Yeah, so we can see.
See, that's how you would trace them. Yeah,
Yeah, that's the way that you lay them down on
yeah.
the plan.
Because the other plane
I'm
would
not
be
sure how you do that.
That one
like
would
this,
have to be.
like that. So that's one concept, and of course, as Reuben and Tony have told you, you can also cut them in the body plan. This is typically how that
Yeah, and also
that dimension is depicted two-dimensionally.
they often, one reason why models are often rare is that the builders would saw them up, because that's the best way to get those sections. If you're to saw them and carve them out of a solid block or a glue together block, rather than separate them in this plane, you could saw them in this plane to get those sectional shapes and extrapolate that way.
And you're looking at a real artifact. You're looking at something from the 1830s, at the 1820s, I believe this is. And so this is at the very beginning of this technology becoming, and this just general approach, becoming a design system in the United States. So that's, these are the treasures that are in museums that you don't generally get to sort of access unless you come in. However, what we're trying to do is turn that on its head and make everyone a museum curator, so that literally you can come in virtually and you can access this vast amount of material, because the design that's embedded in the drawings is it's mind-boggling. The approaches to problems. So we're hoping that not only students of design and engineering, but anyone who might benefit. So go ahead.
Well, I was going to launch into part B, but I don't need to quite yet. If you've got more to.
Well, I guess one thing I could say, I'll talk about. So what's the shape for B below? If somebody would slide me over that booklet right there, I'll talk to you a little bit about a different system. N.G. Herreshoff was trained. He was trained as a traditional boat builder, and so his natural first stage of realizing a design idea was to sculpt it, was to carve a model, and but his approach was to carve a very precise model. Once he did that, once he was satisfied that shape was what he was attempting to achieve, then he would take. He had an apparatus, an instrument for taking a very precision instrument, much more precision instrument than you use, and he had a machined table that the model would be firmly placed down on, and he would arbitrarily divide the model into stations, just like every plan here has stations, and in fact, there's how many stations do we count on that plan? There's a number.
56, 57.
57. So you'll see that actually 51 probably. I'll bet you that's 51.
Here at the stern.
What?
The farthest out.
Back here.
There's 57 actually.
Yeah, here's 50, 52, 54, 56.
57.
Oh, that's interesting. It doesn't jive with the offset booklet. We've got a problem here. But what his approach was is that he'd take that shape at each station, and so here's 0 and here's 1, and so that's the actual XYZ coordinates.
So just to relate that back to what we were just talking about last in the shop, was that this is not giving, it's actually this tool that he had actually gave offsets, actually gave the measurement in feet, inches, eighths, right? So he never had to go through the step of drawing the lines plan. His machine, as opposed to my Rube Goldberg contraption, actually gave you the measurement and scale.
And there was a scale.
And so he never had to take that step of drawing the lines plan.
And what's interesting, because the model is highly precision, he had a scale, and so these numbers, depending on what the scale of the plan was intended to be, or the scale of the model, excuse me, because that's the basis. It just so happens that the model scale is going to be the same as the construction plan scale. Then that would automatically give you the full size dimensions. And
he also had an incredibly skilled and cooperative loftsman, who would make corrections as he went.
And then when they actually made the molds, they would actually do the fairing on the molds. So you'll find occasionally in the offset booklets where there's a number crossed out and a new number written in. And that's so after they made the molds at that particular stage, they said, no, actually it should be this number. And they correct the offsets. So these are corrected offsets, developed from a model, scaled up automatically, and then corrected by hand. And then that's the record. So that's a different system than a lot of other builders at that. Well, we don't know exactly, because we don't know a heck of a lot about all of the Herreshoff. What's brilliant is that it's a very large and very diverse design collection, both naval architecture, marine engineering. There's 30 different sizes of steam engine drawings in this collection. Every bit of hardware, all the drawings for every component exist, not just the designs of the vessels, but everything that went into the vessels. And so we know a fair amount about the way they did it. We don't know for some of the other companies where there isn't so much evidence. So that's a little bit of hopefully dovetailing with what you've been doing.
Well, so we don't want to. We don't have a lot of time, so we won't go too much with it. But just a couple of things to look at. I mean, we'll move things around as we go along. But what you all ought to do is go around the room and look at how in drawing the line span, there are different conventions and different ways of representing the shape. You'll notice in the bow there are measurements. There outside of the offsets, there are other measurements to give that sudden curve of the bow. And then in some of the line span for the P-class boat, they actually show the waterline half breadth shape on the fin portion. Now, right on that one profile view, but the different ways of relating the shape, and you can kind of see how they solve problems they came up with in drawing. But the other thing that we haven't talked about at all is that the line span, like the half model, is only an expression of the shape of the boat. There's nothing necessarily literal, right, in construction in that line span drawing. Your frames don't necessarily line up, and often shouldn't line up with your sectional shapes. So a lot of these plans will have construction plans, and you can see how they would trace over the outline of the line span and come up with these construction details. And there's a lot of, as a builder, this is the thing you spend your time with. Everything you need to know about the boat usually is right here, and you can scale. You have your scaling rule. I mean, any decent boat builder has a rule in their pocket I just call myself a decent boat builder. There's a scaling rule in their pocket that they can scale right to the plans. But take a good close look at how these details were handled. Yeah, right. Yeah, right in a computer. All kinds of engineering details. There's strapping for stiffening the deck. There's all kinds of dimensions written into the scale, and of course, fastening schedules. There's all kinds of details. Where to cut the scarf for the stem. I mean, there's just a load of stuff in here, and you can kind of see how informative this sort of plan is for the builder. That's my rant on the plans, more or less. But yeah, definitely be looking at all of these different ways of drawing.
Yeah,
And the chine boat has different requirements than the round bottom and the fin.
Why are there holes in this one?
But that's a great question. What they did was they made a half model from that plan. Basically, they put planks of wood and they made holes that define these shapes, and then they glued them together and fared them down to make that shape. That's how you make a half model from the plan.
Yeah, for instance, when you already have a drawing and you want to create a model, you don't start with a block.
Yeah.
You then you take and create a bunch of layers, but then on each of them you trace or prick through the shape of that water line, and you at least ink or pencil that accurate line very carefully on there, and cut quite close to that, and then you glue them all together in a stack, so that you end up with a stair step model.
Remember that one I had down just south the end?
That dark brown one there, and then when you plane away everything that removes the stair steps, and you have a kind of knowledge that you guys are starting to get a glimpse of in the last couple of days about how to make these decisions about how to carve it away, because it isn't just, you can't just sort of hack away. You're interpreting as you go. Then you end up with a model that accurately reflects the plan. And if at any point you decide that no, you need to go further than where those inked edges were, then you're actually you understand at that point that you're now making a change from the
and I think that's one way to think about how quote unquote scientifically a half model carver might evolve a design. Like they may use this to make a half model, but add a little bit here, or take away some somewhere else, and then shape the model and use that as a way to develop an idea. So they're beginning
you know, almost literally with this shape, but then developing it just a bit.
Yeah, and then you can also see here,
Oh, yeah, that's
this,
really cool.
first off, the scale of these drawings. How these are much larger, physically larger drawings than the models or drawings that we've been working on. Because again, by doubling or even tripling the size, you're increasing the accuracy of the result. You're giving yourself more room to work. These are also larger boats, so again, to keep the same level of accuracy that most of your models have been, you'd need to make the drawing bigger just to keep the scale right.
There's a drawing on the wall as we go out. You'll see it's about what, 8 feet long. That
Right.
That
Yeah, well, here's a couple of examples in here that we can look at. There may be some lines in here. This is Union Iron Works. This is shipbuilding stuff here. And although I think some of the lines may be, you know, these are a lot of hardware details, but there's here we go. Here's a
steamer.
again, these plans are from you know, early. I think these are early 1900s. Some of these are 1800s. In fact, this is isn't this going to be the same
That's a
vessel?
Construction plan for the hull.
Oh, this is different, you know, line, you know, certain displacements for freshwater and saltwater. There's all kinds of curves here.
Right.
So,
And what interesting thing about these steamers is that they're kind of at an intersection between Sebastian's high-speed sailing dinghy and some of the early kinds of rowing shells and some of the power vessels.
Here's a fabulous plan. You don't see this type of plan very often, but you've got it all in one plan
Oh, yeah,
here.
yeah, yeah,
yeah.
yeah, every detail. And superimposing the half breadth
Yeah.
over the profile.
Yes, so this is a whaleboat, which was a kind of lifeboat or gig used on the USS Olympia, which was a battleship in the Great White Fleet, Teddy Roosevelt's Great White Fleet.
Isn't that the one that's still?
It's
There's
late
a
19th
model.
century.
There's a model of it right over, I think, of the Olympia over there, maybe or the
Oh,
Brooklyn.
there is. That's right.
Yeah,
Isn't the Olympia the one still in Philadelphia?
yeah,
It's still in
Yeah.
Philadelphia.
It's a treat. I mean, it's a
Yeah.
heck of a vessel
Yeah.
to see if you're ever down there.
yeah, and then of course the whaleboat type comes from back, you know, was really one of the whaleboats of the world was evolved just in southern New England in New Bedford and in the Cape and Islands.
Another interesting feature of this, for the use of the boat, is that this rig is meant to be, it's called a knockdown rig, which doesn't mean you knocks the boat down, but the whole thing can be collapsed to fit inside the boat. All those yards
is the
are
kind of
shorter
thing
than a
that
boat.
we
That's what
do
you were
with your
talking about
boat.
before
Yeah.
too.
Yeah.
So you can, when you're rowing it, the rig is out of the way.
And you see how here also, this is often done when you're actually lofting to save space. You actually put all three of the views collapsed right on top of each other, just because you don't want an acre of space on the floor to do this. But you see that you can still maintain visual clarity between them all.
And look how wonderfully these are drawn. I mean, the workmanship of these drawings is really stunning. I mean, the thing. I mean, you really see how well it's done.
I mean, there's
Yeah,
art.
it really is
There
something
really
else.
is
And
well,
even
discipline.
compared to
you
the
know.
the Royal Draftsmen of the
Yeah,
1750s too. They're like on another planet.
Yeah,
Yeah.
Those guys are real.
Could this be silk? I mean,
No,
some
no,
of them
no,
appear to be
they're-
linen, but this doesn't appear to be linen. It's
no.
just a very fine linen,
It's
right?
just a different grade of linen. It's,
Yeah.
it's that higher late 19th century grade
Yeah,
of linen.
yeah. You see, these translucent drawings were done on linen. It's I wanted
Are there
to
any scales on any of these things? Does anybody see
Uh,
that? That's something
gotta
that
be.
when you're, a lot of the plans will have a scale.
scale
on it.
one.
No, I
Equals
mean
1
the
foot.
Oh,
scaling,
actually
the
a
scaling
scale.
rule.
Half inch
Because
equals 1 foot.
Yeah.
with different humidities,
No.
the paper would stretch.
Frank, get
And
the-
so if you're
get the,
scaling off it, the paper would have a scaling
thing that you have.
drawn on it, so you'd use that to measure by
You
rather
can
than
then
the
check
ruler.
that-
You double
that.
check your
Yeah,
measurement,
yeah,
exactly.
yeah.
So you'd measure something with a pair of dividers,
We have
not
a-
a ruler, but then and take it to the scale. to
I'll get
measure.
an example out for you.
But I just wanted to briefly come back to these three drawings, and the way they show the work process here. This
Oh yeah.
this
is very
first
cool.
manila paper sheet, this buff sheet, you see this is where he started working on the design, and then he save as, then went on to
Yeah.
this transparency put over top. But here how he, it's very faint and a lot of glare, but if you get a chance to really take a look at, is maybe help everybody see a little bit more. It has the water lines, it has the profile, it has the body plan all superimposed. It has the diagonals, which show here, and that you can see what he meant, which diagonals he chose here. See, they're arbitrary, but they're chosen with a purpose. And then this curve here, we didn't get to this at all.
We talked about the group of areas, actually.
About taking and from the body plan, getting the area that's enclosed by the underwater portion of each of the sections, and then you plug that into a formula that's going to give you the displacement of the boat, but it also is going to give you some, the areas at each station. And if you plot those out like a graph using the actual literal stations,
a square measurement, but you express it as a linear measurement to get the graph.
Coming up, and then you make a graph of that, because that's the graph actually, not a line in space. That shows you the disposition of that displacement across the length of the boat. Now you see here this particular boat, as you could kind of tell into it just by looking at the fine ends and the fuller middle, the displacement starts out quite skinny, and then kind of gradually grows up to a big lump in the middle, and then drops back
and
off
your boat
again.
has some of that character as well.
Right. Well, actually,
in a very different way.
Yeah. Actually, your boat is much more. It'd be a much flatter.
Much flatter than that.
Flatter than this.
But still concentrating buoyancy in the middle. Like
that. But there'd be an area more like so under it, and that's a way to take and visually represent the way some of that analysis would go, and then of course from that too you can get a sense of where the center of buoyancy is, because the center of buoyancy is going to be in the middle of this space,
yeah, you could simply cut it out on cardboard and balance,
it
and find that center plane.
And the center of the load water line gives you the center of flotation, which is different from the center of buoyancy, because that's just the center of the plane that the whole submerged part of the boat takes up. And again, as we mentioned before about the diagonals, you can see how there's certain because of these geometric right angle cuts that create the water lines or the buttocks. In certain places they end up looking kind of weird and have nothing to do with the flow of the water might be, or the run of the material planking, whereas these diagonals are chosen in a way as to be kind of more or less normal to the overall surface, in a way that ends up giving you another way of seeing how fair the flow of water would be over the surface.
The curve of the buttocks and profile are not even drawn on this plan.
Right.
They'd be superfluous.
Right.
Also, these water lines, down at the fin, they would be all stacked up, were they in that drawing? So they're drawn right on the water line plane, right down
see,
there.
and how each one of these looks like an airfoil, because really this is a foil. This is a foil just like a wing of an airplane, and where these weren't necessarily taken from actual NACA foils at this time. This is what, 1916. There really weren't any at that point CA foils, but the whole idea, the idea of trying to make a actually probably argue that the whole idea of a foil shape of a really started with boats, and then was only adopted by aviation later, because at this point airplanes had wings that were just curved on the top, but not and curved on the bottom too, not foil. Okay, so then went from this and then put this over it and made slight. If you actually put this over there, and I'm not saying we take the time to do it, but you're probably going to find that there are some minor adjustments and revisions that happened in here. Then we went to the model. The model was probably actually a good selling point too. There's something to show the owner, because as you probably can now realize from last week, if you'd looked at these things, they would be meaningless to you. You'd just say, well, yeah, that's the kind of nice looking squiggles on that paper, but I have no idea what you're showing me. So, the owners of these boats are probably not going to see anything here, but if you show them a nice big beautiful model and it's nice and shiny mahogany, they're going to go, oh yeah, I'll write a check for that.
There's little windows cut in there, I guess, to orient the plan. Huh?
Yeah, probably. Yeah.
And then it's drawn differently and more cleanly. The body sections are drawn differently.
Yeah, yeah.
Either diagonals or water lines shown, but not diagonals. So another drawing might show the diagonals.
Yeah,
Together.
and
So
I would guess
it's a
too that
cleaner
there were more of these
Yeah.
save as layers between this before you got to the point of working this final construction plan.
And
But-
there's one other version actually in the folder there. He took an old exam book with him up to Hodgson Brothers apparently and said, and how closely did they build it? And he has all the variations at all the
Oh, is that what
stations.
came up with?
Yeah.
And a little escape clause.
Yeah. So probably trying to beat the judges because it's a
sure.
boat built to a rule.
Yeah.
Sure.
And he didn't want the judges coming saying, oh no, your boat's too big
Yeah,
for our
yeah,
class.
yeah, yeah. How are you for time? Do we have, it's
I don't
10
know
after
what- I
2.
don't- Yeah, we probably should shove along actually,
Okay.
if that's
All
all
right.
right, and look at.
Question.
Yeah.
These
Yes,
guys right
question.
here, the grains, I guess, is that, but just
Those
the
are-
wood drawn on there
Yeah.
to show the grains
Yes.
or
Yeah.
how it
Yeah,
answers?
yeah.
So that-
I
that's
mean,
a piece
that's
of
that's the level of sort of that craft. You know, is there was a love.
Well, a lot of times they were colored.
There was a lot of love going on in that craft, and
Yeah.
it was
Yeah.
it was trying to give it's a working plan, you know. But you'll see, especially in that
That's pretty
19th
built up,
century
isn't it?
period, late 19th century period, there's an awful lot of that sort of illustration.
Yeah. But this is really interesting as from an engineering viewpoint because here you've got a structure. It's 200 feet long, and it's made out of timber, and it has to be fairly light. But it's also because of its shape. It's not a very strong shape. It's just a long, skinny, flimsy shape. So and it's going to have this tremendously heavy and full of vibration, big steam, engine business in the middle here, and this enormous superstructure, which you can all guess at, that makes it a ferry steamer, 3 or 4 decks on top. And so basically what they're trying to do is create a girder structure here, kind of like a bridge, right? With all of these diagonal
trusses?
braces and trusses and things,
Yeah,
right?
sure.
To create, and then this enormous thickness of all those layers of keel and these kind of big frames in there. They're sandwiched between inner and outer keels and everything to just create girders and trusses to give enough strength to this thing and enough stability, physical, to keep it from flexing, so that the thing would actually work and have some sort of a life. And of course, these things didn't really last that long, not just because wood is perishable, but because they're pushing the engineering of a structure made out of these
Well,
materials.
it's a little bit more stress than a bridge has to deal
A
with.
lot more stress than a
Because
bridge, yeah.
because it's carrying a weight in a dynamic environment,
Right.
and a bridge's dynamics are aerodynamics and load and
And load, yeah,
aerodynamics.
right, right.
But
Yeah. So and you can just imagine if they hauled this boat out, this ship out, and they and the blocking that supported it on the ground wasn't exactly right, how they could easily just break the whole thing in half, or if it ran against the rock on one end and the tide went out. I mean, you could there's enormous strains on the structure, and it's not very strong structure because of its shape and because of the limitations of the material. And whereas which is kind of the same kind of problem that Sonder boat has, but is not a problem with this shape of boat. This boat, because it has a lot of curvature and more reasonable proportions overall, is going to have kind of the way eggshell an egg has strength because of its shape versus having strength. It's a very brittle material, but because of its shape, it's enormously strong. So this is a strong shape. That's a weak shape, and that required a lot of engineering to make that into a strong thing. And the same with that. Whereas this one or that one, they're more reasonable shapes and end up becoming reasonable in the sense of having strength inherent in the shape.
Yeah.
So they required less engineering and less structure to make them strong. These boats didn't last very long because you're pushing the materials, beyond their limit, and these would be much more conservative as far as their longevity. And of course, this is an even more conservative shape that's reasonable and easy to build out of material.
there's this shape, this choice in materials might actually be because of where the shipyard was.
Yeah, and the time, yeah.
Yeah, I mean, this has got to, is there a date on here? This has got to be turn of the century.
San Francisco.
I don't see any date on here, but my guess is that it was
Well,
turn of the century.
Yeah.
And you would have expected it to have been built out of steel, but it was on the West Coast, and there was a huge abundance of that material, and so
Yeah, there's probably a forest of Douglas fir and redwoods building that, but they were local, whereas the steel would have had to come from Pennsylvania or something around the Horn, and would have not been economical for them at the time. You see here, you can see all the top hamper that isn't shown on here. This block here is equal to that cylinder there, which is the boiler. But then there was all of these decks above. I mean, this thing was up to here.
Oh, wow.
Next one, Bond, right?
okay.
Yeah.
Oh, yeah.
The construction plan than yours. Yeah.
Future class, you'll be able
It's
to
different.
preview the collections digitally and have
Yours
a lot
is more of a
choices.
historical type.
Okay.